So for question 3, we've got 16a squared is equal to 2 root a. We want to find all the real solutions for this using algebra. So you can't use trial and error and just substituting numbers, you'd get no marks because it specifically says in the question that you must use algebra. So if we look at this expression, well, the first thing is we don't really like this square root. So let's change that into index notation. And if it's the square root of a, that's a to the power of a half. So we've got 16a squared is equal to 2a to the power of a half. And whenever you're solving an equation like this, we want to get the a terms onto one side. Now, you can divide by the a to the half to move it, but you've got to be very careful if you do that. So the much safer move is to subtract it. So 2a to the half is equal to 0, just like you would if it was a quadratic or a cubic. It's at this stage we can take out a common factor, or in this case 2 common factors. Well, we have 2, and we can take out the a to the half. If we do this, that leaves us with 8a, 2 minus the half, which is 3 over 2. If you re-expand that, you would add the powers, which gets you back to the 2, minus 1 is equal to 0. So this really tells us two things. We've got 2a to the half is equal to 0. 8a to the 3 over 2 minus 1 is equal to 0. Well, the only solution possible for this is to say that a is equal to 0, and indeed that is one of the solutions, and that's the one that you're likely to lose a mark for if you're not careful. Then we need to rearrange this, so we can say that a to the 3 over 2 is equal to 1 over 8. Now, if we move the powers to the other side, it's basically going to flip the powers, so a is equal to 1 over 8 to the power of 2 over 3. We can deal with these separately. You've really got a power of 1 over 3 and a power of 2. The power of 1 over 3 is a cube root. So the cube root of 1 is 1, the cube root of 8 is 2, but we've still got the power of 2 there, so we just need to square it. 1 squared is 1, 2 squared is 4, so a is equal to a quarter. And I just write one final line, just clarifying that. A is equal to 0, a is equal to a quarter. Those are our two solutions there. Okay, and that will get you the 4 marks. Moving on to question 4, we've got a bit of integration. Well, we've got an integration where we've got a general x where, k, where k is just a constant. So we can carry that through in the integration. In part B, we'll use some extra information to actually solve and get a value for k. Now, before we integrate this, we don't like this fraction, this over x cubed. So let's convert that such that we've got 4x to the minus 3. We bring it up into the numerator, it picks up a minus in the power, plus kx dx. Now we're ready to integrate. When we integrate to the reverse of differentiation, so instead we add 1 to the power, so we've got 4x to the minus 2, and then you divide by the new power, so in this case we divide by minus 2, plus kx, we raise the power by 1, so it's power of 2, divide by the new power of 2, and you can't forget your constant of integration. Because remember, if we were taking this and differentiating it backwards, if there was a constant there, like back in question 1 where there was a 16, when you differentiate it, the constant goes to 0, so there is possibly a constant there. It might be 0, but it might not be, so we've got to have the plus c. So just tying this up then, we can say we've got minus 2 over x squared plus k x squared over 2 plus c. You could write this as minus 2x to the minus 2 instead, but actually this form's generally going to be simpler if we're substituting it, which is what we're going to do in part B. So part B, we can actually take this solution, because instead of an indefinite integral, we've now been given a definite integral with these limits, and we're told that it's equal to 8, so we're going to be able to solve for k. So we can take our solution and say that when we integrate this expression, we get minus 2 over x squared plus k x squared over 2. We don't need the plus c because we have our limits of 2 and 0.5. And yes, we can put that that's equal to 8 again, fine, just to clarify that. Now, with our limits, we substitute in the upper limit, so we substitute in 2 first. So you got minus 2 over 2 squared plus k 2 squared over 2. Subtract, and then substitute in the lower limit, minus 2 over, and I'll convert that into a fraction, a half squared plus k a half squared over 2, and that's all equal to 8. If we simplify this, we've got 2 squared, which is 4, so minus 2 over 4, which is minus a half. 2 squared, which is 4 divided by 2, so plus 2k, minus a half squared is a quarter, minus 2 divided by a quarter, minus 8, half squared a quarter divided by 2, an eighth, so plus k over 8. Because we've got this minus, if we expand it, so we've really got minus a half plus 2k plus 8 minus k over 8, and let's put there that that's equal to 8. Combining these then, 2k minus k over 8, and you get 15 over 8k. The 8 and this 8, when it moves, it becomes a subtraction, so they're really going to cancel. The half, when it moves, becomes plus a half. So k is a half times 8 over 15, which is equal to 4 over 15. So k is equal to 4 over 15, and that should be your final solution for k.